Thank you for joining us today. We will focus today on building Delta Life tables or declarative pipelines as they were renamed, only with SQL. I'm Bianca Stratulat. I'm the Chief Data Officer at Unifeye, and today I have with me Stephen and Jordan from my team. But before handing over to them, let's just a quick word about Unifeye. Unifeye is a Databricks partner and the organization behind this user group. At Unifeye, we focus 100% on Databricks. Everything we do is around helping organizations get faster value from the Databricks platform. We build accelerators, training programs, and managed service that simplifies the data and AI transformations from Unity Catalog deployment and Delta Life Tables pipeline all the way to the AI-powered analytics. Our goal is quite simple. We make data engineering, governance, and AI adoption easier, faster, and more accessible, not just for the data engineers, but for the wider business, all that using Databricks. So I would like to give you more context why Delta Life Tables only with SQL. We need to look at the business context for that. Many organizations today still depend on very manual ETL processes or complex code-heavy pipelines that require deep engineering support. That's fine for certain workloads, but it slows everything down when analysts or business teams just want to move quickly and get insights. We often hear the same challenge. I know what transformation I need, but I have to wait for a data engineer to build it. That dependency becomes a bottleneck. This is why where Delta Life Tables come in. They make possible to create declarative production-ready pipelines with just SQL. Of course, not only SQL, you can do it in other programming languages as well, but today we are focusing only onto the SQL as I iterated. So rather than writing hundreds of lines of Python or managing orchestration logic, you define what you want the data to look like, and the database handles how to make it happen. That means analysts and engineers can now collaborate in the same environment using familiar SQL syntax, while database take care of the reliability, the lineage, and even testing automatically. And we will show this today. For the business, that translates directly into faster insights, better data quality, and consistent governance across every data set without the complexity that typically slows the teams down. Let's go through the agenda today, what you will learn today and what we are going to cover, and what you will walk away with. First, we are going to start with the data ingestion. We are going to cover autoloader and the lake flow to connect to a raw data source, automatically detect the schema and bring that data into a bronze layer. This is where we capture everything in its raw form, fast, reliable, and schema aware. Next, we are going to move to the silver layer where the real transformation happens. Here, we will apply the business logic, cleansing, and data quality rules directly within the Delta Life table using SQL. We will then push into the gold layer where we will design aggregations and make a simple star schema ready for analytics or BI tools. Finally, we will wrap up with the deployment demo, showing you how you can promote your code using databases and bundles. This allows you to version, automate, and deploy pipelines across environments, or actually different workspaces, dev, test, and prod, in a repeatable, governed way. So by the end of the session, you will see the full journey from raw ingestion to production deployment, all built declaratively using SQL only. I will go now into the Lakeflow declarative pipelines. These are the Databricks vision for the next generation of ETL. If you have been following the recent announcements from Databricks, you will know that Lakeflow brings together ingestion, transformation, and orchestration all in one unified framework. Essentially, Lakeflow is the new umbrella for how Databricks wants to make data engineering declarative. Instead of building dozens of jobs and writing complex logic for every transformation, you now describe what needs to happen, and the Lakeflow figures out how to make it happen. So think of Lakeflow as a single end-to-end ETL platform, tightly integrated within the Lakehouse, designed for reliability, scalability, and ease of use. Now, when we say Lakeflow is a complete ETL tool, what does that actually mean? It covers the entire life cycle of your data pipeline. First, you have Lakeflow Connect. This is your ingestion layer. It helps you bring data from multiple sources, files, APIs, databases, even streaming directly into the Lakehouse. And does it with schema inference, auto loading, and the built-in connectors. Then you have the Lakeflow declarative pipelines, the DLTs. This is where the transformations happens. This is what we will focus on in today's session. It's all about defining how data flows from bronze to silver to gold without worrying about orchestration or dependencies. And finally, Lakeflow workflows, which handle the orchestration, chaining together tasks, running them in sequence or in parallel, managing dependencies, and monitoring everything through the Databricks interface. Together, these three pieces connect declarative pipelines and workflows, make Lakeflow a very complete and modern ETL solution that is tightly integrated with Delta and with Unity Catalog. So why we should care about the Lakeflow declarative pipelines? What makes them different from traditional ETL tools or even existing DLT pipelines? The first reason is focus. Instead of managing the complexity of pipelines, triggers, retries, orchestration, you focus purely on transformations. You declare the logic and database handles the rest. Dependency resolution, execution order, recovery, and optimization. It's a huge productivity boost, especially for teams that want to move quickly, but still stay governed. The second reason is accessibility. You can use pure SQL. You don't need to know PySpark or even Python. That means analysts, data engineers, and even less technical users can all build, test, and maintain production-grade pipelines in a single environment. This is a big deal for organizations trying to democratize data because it brings everyone closer together onto the same platform. And the third reason is unification. Lakeflow declarative pipelines provide a single API for both batch and streaming workloads. So whatever your data is coming in real time for Kafka or hourly from S3, you can define your logic once and let Databricks handle the mode of the execution. In other words, you no longer have to build two different pipelines, one for streaming, one for batch. You simply define what you want your target table to look like, and Lakeflow manages the rest behind the scenes. So to summarize, and to put this into just simple words, Lakeflow gives you the ingestion, the orchestration, and orchestration. So give you the ingestion, transformation, and orchestrations, all declarative, all native to Databricks in one single place. I will hand over now to Stephen, which will cover the autoloader.
Thanks, Bianca. Could you go to the next slide, please?
Yes.
Thank you. Yep. So hi, I'm Stephen. I'm a data engineer at Unifeye. I thought I'd cover some autoloader stuff and then what we're building today as part of the demo. Could you go to the next slide, please? Yep. So one of the ways to ingest data into your lakehouse is through this tool called autoloader. So imagine you have loads of files in S3 or Azure Blob storage and you want to load those into your Databricks lakehouse. You kind of want to grab those incrementally every time a new file lands. So Databricks Autoloader basically gives you a structured streaming source to do that. You can do this in Python or SQL to load all of your data files into your lakehouse. It's a really seamless way to load data in. And if you have any partitioning, you can create a partition data set as well, this kind of process. Could you go to the next slide, please? Yep. So right now I'm going to talk about the pipeline overview of what we're building, like our medallion architecture, how DLTs tie into that, and how we built it with just SQL. So you don't need any Python to get started in Databricks building these pipelines. Could you go to the next slide, please? Thanks. Yep, so for this demo, we're using the quite popular New York City taxi cab dataset. So we've loaded that into a data source Azure SQL database. And we're streaming that into the bronze layer using an ingestion pipeline. So we're not using autoloader for this use case. That would be a different way to do it. So you could load in your files to Azure Blob Storage S3 and use autoloader to load that into the bronze layer rather than the ingestion pipeline. So our bronze layer are just the raw data basically with a schema applied. So we have streaming tables like taxi raw records, and we also have an expectation to drop records which violate a certain rule. And once we move on to the silver layer, we're just in basic transformations. So I have a flagged rides table and weekly stats, which just do some aggregations before passing on to the gold layer. So the gold layer is obviously where we have all the aggregated data that goes into BI dashboards and everything's for the business. To help your business make data-informed decisions, you would use the gold layer in all your dashboarding in Databricks, essentially. And all of this can be built with just SQL, so you don't need any Python transformations or complex PySpark logic to do any of this. Could you go to the next slide, please? Yep. So the way you deploy this, the way you do this usually is through the Databricks user interface. So if you're not very technical, you can go in and create a new notebook, get started with SQL very easily. You don't have to set up an IDE, any kind of command line tools to deploy asset bundles. But if you're kind of more technical, you can go with Databricks Asset Bundles, which allows you to have more kind of fine-grained control in your continuous integration and delivery pipelines. So if you go to the next slide, please. So this is kind of based on the infrastructure as code concept. So you have code that kind of defines your infrastructure, your compute resources, your wheel files for your Python code, and different things like that. So for this, you usually have some Python packaging. Sorry, could you? For this, you would kind of build your Python package and also your YAML file. So the YAML file defines which computer you're going to use, how to build the DLT pipelines, the different sources, the transformations, the destination. And this just basically includes all of your assets and source files that you need to deploy very easily. So if you imagine you're doing this with SQL or Python, you can do your unit testing here very easily. So you can create a local Spark session, test all of your functions in isolation, and then only when that build passes, you deploy to Databricks development environment and push that through to production. So this gives you more fine-grained control around your CI/CD process and deploying to Databricks, which is quite nice. Go to the next slide, please. Next one, please. So when you're testing Python, it's very easy to test functions as units of code. So you have a function which takes a PySpark data frame as a parameter, and it returns a PySpark data frame. So you can test the kind of transformation logic and the output is what you expect. So you test for edge cases, like any values that would break the function, test that it still works essentially. And your code is quite resilient. And if any of these tests fail, then the CI pipeline will fail and your code will not be pushed to Databricks. So it's kind of a nice way to stop any bad code getting into your Databricks environment and your development test production workspaces. But with SQL, this is a bit harder because you can't just have those functions or units of code to do that with PyTest. So this is one drawback of doing pipelines only in SQL, but it's a lot easier if you're not technical enough to write Python code or to write your unit tests in Python. But testing is really critical still. So another way to do this is like integration tests and expectations. You could argue these are more data quality checks rather than functional like Python code checks. But it's still an extra layer to make sure your code is really high quality and you're getting the results you want. If you go to the next slide, please. Yep. Here I will pass over to Jordan, who has just joined us for the demo of this in the Databricks Asset Bundle.
Brilliant. Thank you, Stephen. Yeah, I'll present the demo. I just need to share my screen. Let's see. Okay. Oh, well, actually, sorry. Would you mind trying this again? Can I share my whole screen? Share something else. Window. Entire screen. Okay, here we go. Yep. Can you see my screen? It's just VS Code right now. It's empty.
Yes.
Okay, brilliant. Okay, thank you. So thanks, Stephen. Stephen mentioned about Databricks Asset Bundles. So I'm going to show you those first, and then we'll get into the actual Databricks UI, and we can see what we actually make. I think it's definitely worth looking into Asset Bundles because they're great. It's definitely worth spending the time. So what they are essentially is a collection of your code, any assets that you're going to have in Databricks, like jobs and pipelines, dashboards, and also tests. In this case, I don't have any tests really. As Stephen mentioned, we're going to be focusing on like the kind of integration tests which are going to be incorporated into our pipeline. And then I have a resources folder and an SRC like source code folder. I'll quickly just touch on resources. This is, or these are YAML files which define your jobs and pipelines. We're going to be creating a pipeline that ingests data from SQL Server and then moves it through the typical medallion sort of bronze, silver, gold steps. The first two files that you see here, gateway and ingestion pipeline, are not maybe the focus of today, but they're essentially a way for us to, they are the ingestion step. They are how we get data from SQL Server into Databricks. And I'll show you how you would do that in the UI. It's part of Lakeflow Connect, which is like a kind of new feature of Databricks, which, well, Lakeflow Connect is essentially like a collection of connectors that essentially make it very easy to ingest data into Databricks from different source systems. So we thought it would be good to have a look at that today. But the focus is on the actual building of the pipeline with only SQL. So everything that we've got for the actual pipeline downstream of the ingestion is just created in SQL. There is a YAML definition for it. It's quite simple. You don't need to know how to write it. You can export it from the Databricks UI, which I'll show in a bit. So I wouldn't worry about having to create that. You can just create the pipeline in the UI. It's no problem. But essentially what we have here under SRC are our steps. We have bronze, silver, gold, and we also just have like a separate file for just integration tests as an example. So in bronze, what we're doing is we are essentially just reading from our ingested data. We're ingesting data into the SQL Server ingestion and then NYC taxi trips table. We do add a constraint. So constraints is called an expectation. There's like 3 different kinds of expectations. They're a way to enforce data quality checks on your data, and that will form the basis of our integration test. But you can also just add them to any table that you want. For example, in this bronze table, we're going to get rid of any trips that don't really make sense for the taxi trips. If the trip distance is 0 or less, then that doesn't make sense. So we're going to just drop those rows. That's the only constraint we've got. You can have other actions take place if a check fails. For example, you could just have a warning, but continue anyway. Or you can drop rows in this case, or you can fail the pipeline. Yeah, because that maybe indicates a more serious error if that constraint fails. So that's bronze, simply reading the data as is and applying a small constraint. Silver, we've got 2 silver tables, a streaming table and a materialized view, which are essentially just reading the bronze table that we made, and then maybe just doing some filtering or some grouping and aggregation. And then, well, I'll go to gold first. We have the materialized view for gold. So yes, finally, silver integration test. This is what I wanted to show. I've actually got 2 integration tests here. They're defined in one constraint, but we've got an OR statement to expect that the trip distance, this is the same as before, basically just checks that the original constraint worked. The trip distance is greater than 0, and that the fare amount is also greater than 0. I don't want anyone getting free trips, so we check for that as well. Now I'm just going to run this command. This is just to show you how easy it is to deploy resources with Databricks Asset Bundles. I've got these files in this bundle, and I can just run this Databricks bundle deploy, and then I'm telling it where to deploy to, and then there's a profile which contains some authentication information which I'm referencing, and so it's able to do it. There is more information in here that specifies exactly where it's going to deploy to, but I don't really want to get into that right now. It'll take too much time. So I'm going to go back to Databricks, and you can see that these 3 jobs have been populated. I've just created those. The first 2, or well, the bottom 2 really, there's the ingestion gateway and the ingestion pipeline. These are, as I mentioned, the 2 parts that form the ingestion from SQL Server. If you wanted to do this in the UI, you could go to, on the left-hand side, data ingestion. I open this. These are the different Databricks connectors. These are like the managed Databricks connectors, which are very easy to use. The latest one, or the last one at the end there, is SQL Server, and you can go through the steps, which are not too difficult. It's just I want to show you, like, there are some things that we've done that we're not really showing as part of the demo that you would need to do if you wanted to implement this. There's some like background work to do. And those things are creating a connection object. So there's a connection object here. It essentially just stores the authentication information for SQL Server, so like a username and password, and then the actual URL for the database. And also there are also some steps. So the way this works, or the way this connector works, is it requires change tracking or change data capture to be enabled on each table that you want to ingest. So there is a bit of source setup to be done. There's some commands that need to be run on the source database. There's a guide for that online, so it's fairly straightforward. I think this might take a little bit to run, so I'll just show you the table that we're ingesting in Gateway, or no, sorry, the ingestion pipeline. Essentially, in this YAML definition of the pipeline, or you can do this in the UI as well. You would just have to specify each table that you want to bring in. I'm looking. We've got, okay. This was our database, or is called this, or our server is called this. Yeah, whatever kind of name. The database is called DBO, and then the table is just the NYC taxi trips that we're going to ingest. You could, for each table that you want to ingest, just list them here. And then I specify where in Databricks I want to save the data. So I want to save the data to a specific catalog and a specific schema, which we've used some variables here. It's worth pointing out just another feature of asset bundles. It's very easy to parameterize. So if you want to deploy to different environments or just repeatable deployments for slightly different parameters, it's really easy to work with. So it's worth pointing out. I'll go back to this. So the ingestion gateway is just waiting for resources. It's going to check SQL Server and it's going to ping it and get a response. And then when it's ready, it should just take a few minutes. I can then ingest data. I could have set up a job that runs each step kind of sequentially. As it is, I'll manually just run each step so you can see what's happening. But while I wait for that, I'll just point out that the main pipeline that we're going to be interested in is the SQL Server medallion pipeline. That's what we really want to show today. The ingestion from SQL Server is just kind of extra. This is the one that we're going to be making purely from SQL code. So if I go into the source code here in the job, this is actually the UI that you would get if you made this in the UI. You can create, you can see your files here. Yeah, there's bronze and then gold. And then you can run the pipeline from the UI. It's all very easy. I think I can probably create another file and just add it to the pipeline. So yeah, perfectly possible to do it in the UI and probably how you would start anyway before moving to the bundle. I'll just go back and see if my gateway's getting better. Nearly. It just takes a little bit to run, usually pretty quick. This is like the slowest step. Everything else runs pretty fast because this is using kind of more classic compute for now. Hopefully, as the Lakeflow Connect improves, it'll be possible to use serverless. Not possible yet, but the other steps use serverless, so they're much quicker to spin up and actually start processing the data. So we'll just have to keep an eye on this, but once it starts, it just goes and it does it very quickly. In the meantime, just thinking what I could show. Yeah, just around Lakeflow Connect. I think just if you are using Databricks, I guess the whole point is that you want to ingest data. So this would be my first step. Is always just look at here if you could bring in data from a managed connector. That's going to be your easiest way. So we're lucky here. We've got the SQL Server one, and we can show that off today. This should just take a second longer. In my testing before this, it was already done. But let's see. There we go. Right on time. Slightly late. It's running the ingestion gateway, so you'll see at the bottom. Okay, it has pinged the server. It's got a response. Everything looks like it's fine. So the gateway's running, and it's going to constantly check, and it's going to run continuously for changes. I can then run the ingestion pipeline. And this one will be much quicker. Good news. So it's serverless. Yeah, waiting for resources now, but it runs pretty fast. There we go, initializing. And what you'll see is it will create two tables. So it'll create like a CDC staging table. So that captures the change data capture data. And then there will be a table for the data itself. And the good thing with this connector, and the fact it's got the CDC data, is it kind of manages all of the SCD type 1 or type 2 implementations for you. Like if you want SCD type 1 and you don't really want the history and you just want to overwrite the tables, you can just set that as a parameter. I think the default is SED type 2. So you might notice in my YAML definition of the pipeline, it doesn't specify SED type. So the default is SED type 2. And it's made possible with this CDC stream. So here we go. We've got the taxi trips coming in. We've got 10,000 records, and the actual processing of that data is fast. It's just the initial setting up of the gateway that has to take some time. So that's done. We could go in and see the table in the catalog here. It's been ingested into our SQL Server ingestion NYC taxi trips table. And we've got these columns, and this is the schema essentially. But yes, that's good. I can go back and I can run the last step, which is the main step actually that we want to see, which is our medallion pipeline created entirely in SQL. And the good thing about it is, yeah, we just really wrote SQL code and we specified in the YAML that we want a pipeline, but we didn't have to worry about like, oh, what's the compute going to be like? What's the monitoring going to be like? How are we going to set up all this kind of, you don't need to worry about the deployment or the infrastructure or anything. You can just write SQL code, specify, okay, this is the code I want to run. And then you get this. So Lakeflow declarative pipelines will make this DAG for you. I didn't have to specify anything. I just wrote the SQL code, and it can infer just by reading like, okay, you're reading this table reads that table, and this other table reads that table. It can figure out how everything flows, which is really nice. It's a nice feature of Databricks and Unity Catalog in general, is like data lineage. You can always track like where your data came from and what job created it. So here it's done. We've got the bronze table, which is essentially just a copy of our ingested data. A couple of silver tables, and then we've got that's the integration test, and then that's a final just gold table. So that's all done quite easily. If I go to the table, I should be able to just check out lineage just to show that off as well. So I can't actually remember where I go. Lineage, there we go. So let's see, lineage graph, that's always better. You can see that this table is downstream of a silver or two silver tables, and then you can just keep expanding, which is quite nice. So in Databricks, you can always see where your data is coming from, which is really good. So just you have more trust in your data. But that's it. For me, that's a demo. That's a pipeline created entirely really in SQL. Just to reiterate, yeah, we use Databricks Asset Bundles, but you could do this all in the UI. Like if you're not familiar with kind of these processes, if you'd rather just use the UI, preferably possible, and it's easier actually. Yeah, that's it from me.
Okay, let's come back to the presentation. We have covered today the demo as well, the demo, but let's do a recap of what we have covered today. So we have started with how we see this to ingest data using autoloader and the flow connect, taking care of the schema detection automatically. Then we saw how Delta Lifetime declarative pipelines. Let us use the declarative pipelines just using SQL without worrying about the orchestration for functions. We added data quality rules and expectations, ensuring that the data is trustworthy from the start. We walked through the full bronze, silver, gold journey, transforming the raw data into something that's analytics ready. And finally, we have deployed our pipeline with Databricks Asset Bundles, showing how automation and governance come together beautifully in Databricks. Hopefully, this session showed you how Lakeflow can really accelerate your path from raw data to reliable insights. all with simplicity, governance, and a bit of the Unifeye magic. Now we will be taking questions if there are any questions. Okay, I can see a question from Ian. Thank you very much. What is type 1 and type 2? Who wants to answer that? Jordan, Stephen?
Sure. Yeah. So it's SCD type 1 or type 2. So it's slow changing dimensions. Essentially, you'll have in your source tables maybe some dimensions that will get updated sometimes. And really depends how you want to treat that data. If you have SCD type 1, you might just overwrite essentially that data, and then maybe that's fine. But SCD type 2, there are other types, but SCD type 1 and type 2 are probably the most common. Type 2, essentially you have another field that will tell you, okay, this was the value between these dates, maybe like, yeah, whatever dates. And then there'll be, when that value or when that row is updated, essentially, you've got an end date and a start date. And you know it's not currently the real value. You'll have another row that will be inserted with the current start date, and then maybe like an empty end date or something. But basically what it allows you to do is have like a history of your dimensions and how they've changed. So yeah, it's just different ways of treating data that's going to be changing in your source systems.
In simple ways, the type 1 is overwrite, no history, while with type 2 you have a version, so you keep the history. Every time a record changes, you insert a new one with an updated version and mark the previous one as inactive. That's the big difference. However, in Databricks, this is fully managed if you use the autoloader. Any more questions? Right, then that will be today's session. Hope you have enjoyed, and if you are living with a few learnings. Thank you very much for your time, and I will see you next time. Thank you.
Thank you, everyone.